Hello everyone, welcome to the video lecture series of course Internet of Things. In today's lecture, we are going to discuss the protocol REST, AMPQ, CoAP and MQTT. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have discussed the protocol IPv6, 6LOWPAN and RPN. Now let us discuss the protocol REST, that is REST. REST, representational state transfer, which is referred as a REST-based API, which provides a stateless communication. Let us discuss this in detail. REST is a set of architecture style used for designing network applications, web services, or web APIs that are targets how server resources are addressed and transferred. REST follows request-response type of communication model. Most of the REST API works over HTTP by using the delivery methods that HTTP offers, that is get, put, post, delete, etc. REST-based API follows following characteristics or constraints. Characteristics of REST-based API: stateless, client-server, cacheable, layered system, uniform interface, code on demand. First is stateless. In REST communication, each request receives its own response and it is not related with any other request or reply. Because of this, each request must clearly describe its requirement and specify it in the request itself, as no data from the previous context is available in communication. Client-server. Client-server communication distinguishes work of each side and separates it clearly. As client side will not be bothered about storage and other server work, and server side will not be bothered about GUI development for the user and the front end, that is the client's work. Cacheable. Cache property defines whether the response for any request can be cached or not. If cache feature is on, then data in the response is cached in client and is readily available for reuse for next request. The request need to be implicitly or explicitly labeled as cacheable or non-cacheable. Layered system. Layered system defines the boundaries of the components within each specific layer only. For example, a client as a component cannot tell whether it is connected to the end server or an intermediate node or server. Uniform interface. This constraint specifies that the method of communication between the client and the server should be uniform throughout the communication. For example, resources are identified by URI in web-based system, which is uniform. The data returned by the server to the client has different format and is well understood by client. Code on demand. This constraint provides the server facility of sending executable code and or script to the client, although this constraint is optional and all other are compulsory. A RESTful web service is an API implemented as a combination of HTTP and REST characteristics defined above. Figure shows the REST communication. This figure shows the client-server communication using REST protocol. Figure 1 shows the client-server communication using REST API and Figure B shows the request-response model using the REST. As shown in Figure 2, URI are used to represent resources in a RESTful web service. Client tries to access these resources via URI using commands like put, get, post, delete, etc. defined by HTTP. In response to the request in RESTful web service, server responds with JSON object or XML file. Now let us discuss the AMPQ. Figure shows the AMQP. Figure shows the AMQP architecture. AMQP stands for Advanced Message Queuing Protocol, is an application layer protocol mostly used for business messaging. AMQP uses point-to-point and publish-subscribe model of communication for routing and queuing of the data, which was developed as an open-source replacement for proprietary protocols. Similar to MQTT, AMQP also works on publish-subscribe model, but the broker in AMQP consists of additional part along with the queues which is exchanged. Exchange receives the publisher message and distributes it to the queues based on predefined conditions or fixed roles, if any, of queues. An intermediate AMQP broker manages message and its flow through the network. It receives messages from publisher and routes it to the subscriber consumer. This is done using queuing technique. Published messages are copied into the queues. Messages can either be delivered by the brokers or consumers can pull them from the message queues. Two most important characteristics that makes AMQP famous are interoperability and the reliability. It also provides advanced message features like flexible routing, reliable queuing, security, transaction and topic-based publish and subscribe messaging. Various operations are possible on queues being used in AMQP like manage message depth of the queue, selective access to the queues, etc. Just like MQTT, AMQP also be developed on TCP, which makes the communication reliable. Wide understanding of this messaging protocol makes the protocol interoperable, whether other protocols have already failed. Some famous companies implemented AMQP. JP Morgan uses AMQP for nearly 1 billion messages a day. NASA uses AMQP in its Nebula cloud computing. Google also uses AMQP in complex event processing. India's Aadhaar project has also made use of AMQP. Now let us discuss the CoAP. CoAP stands for the Constraint Application Protocol, invented by the IETF for RESTful environment, which is an application layer protocol used by IoT applications. CoAP can be considered a smaller version of SOAP, specifically designed for low power devices used in the IoT applications. CoAP used for machine to machine, that is M2M communication, where the applications are meant for small embedded devices, control environment and constraint network. Similar to HTTP, CoAP is also a web transfer protocol and follows request response model. CoAP uses client-server communication using UDP-based communication by default and occasionally use TCP. CoAP works with the HTTP to provide the basic support of the web. In this way, proxies can be used to access the CoAP resource via HTTP in a uniform way. Similar to HTTP, CoAP also provides commands like get, put, post, delete, etc. and both are simply interoperable. CoAP works in two main modules, request response module and messaging module. Request response module manages the communication channel while messaging module manages the duplication and reliability of messages in the communication. CoAP has four types of messaging modes: confirmable, non-confirmable, piggyback, separate. First is the confirmable. This type of message defines a reliable communication and message passing. For each connection, message acknowledgement is received, making sure that the message has received at the receiver end. Figure shows the confirmable message. Next is non-confirmable. This type of message provides unreliable communication as there is no ACK, that is acknowledgement, on message passing. Hence, message reception is not assured. So this kind of messaging is used when the loss of packets or messages is sustainable. Figure shows the non-confirmable message. Piggyback. This mechanism is advanced confirmable messages and is used in request response model when a query or request is sent to the server in a client-server communication. Server sends the response to the query within the acknowledgement message itself. The ACK message, that is acknowledgement message itself, contains the response as well. Figure shows the piggyback mode. Next is separate. In this mode, the acknowledgement, that is ACK message, and the response message are sent separately. When a query or request is sent to the server in client-server communication, on reception of connection message, server sends acknowledgement, that is ACK first, making sure the request is received, and ACK is sent first. The response to the query is sent after the acknowledgement message. Response might be delayed by the server. Figure shows the separate mode. CoAP features in brief. Constraint Web Protocol meets M2M application constraint web requirement. Works on UDP, that is by default, with optional support for reliability, and also has unicast and multicast request. Message exchange asynchronous. Header overhead is low. URI and content type support. Simply proxy support provides a network traffic limiting, improved performance, access to the resources even if they are slipping, and of course security to some extent. Also has caching capability. CoAP works with the HTTP to provide the basic support of the web. In this way, proxies can be used to access the CoAP resources via HTTP in a uniform way. Next is MQTT. MQTT stands for the Message Queue Telemetry Transport. Is a famously used IoT protocol. Is an application layer protocol. MQTT was first developed and deployed by the IBM, but few years back IBM made it open source for better development of the protocol. MQTT uses publish-subscribe model of communication. The broker of the publish-subscribe model handles the queues, which manages the topics. In MQTT client-server communication, client connects to the server and publishes a message to topics available on the server. Intermediate broker manages these messages from client and forward it to the consumer subscribed to the topics. MQTT is specially intended for a resource-constrained device having low power, low bandwidth, and network with high latency like dial-up lines and satellite links. MQTT is useful in applications and devices where resources, that is processing and memory, are limited and has low bandwidth. Because of this, MQTT has a low power footprint, which makes it suitable for IoT application development. Figure shows the MQTT architecture. The main aim of MQTT is to collect data from the many devices, sensors distributed in the network, and transport that data to the IT industries for further processing. This goal needs to be done in telemetry fashion, that is remotely with the minimal human intervention. MQTT-based broker can engage thousands of devices connection, and that too concurrently. MQTT works on top of TCP, which maintains the reliability of messages and no data loss is there. MQTT is also helpful in connecting computational devices like Arduino, Raspberry Pi to the web services. Facebook uses MQTT as an integral part of FB mobile applications due to the low power requirements, and it is very light on network bandwidth. MQTT has been assigned port number 1883 without SSL and 8883 for MQTT with the SSL. MQTT is ideal for huge network of small devices and that need to be monitored or controlled via a back end from the internet. Summary of today's lecture. In today's lecture, we discussed the protocol REST, AMQP, CoAP, and MQTT. Thank you.